This conference will now be recorded.
Okay, so we have covered the Kubernetes. So today we'll try to cover, the concepts, the other concepts of the Kubernetes, so that those you have to keep in your mind. And if you get the time, try to explore that one. Like some point of time, those concepts are might be useful. So during your project, or maybe or may not be. There is a chance like you may use or you may not use. Right? But better to have the understanding of the components. So before understanding the components, let me show you how the front end and back end DBs are going to connect one each other in a cluster, right? So because every a component is an individual server, right? And the individual server is nothing but it's a container. So now here in our microservice world, the entire application will be divided into pieces. Each piece will be deployed as a separate server. So now the servers we are going to talk as a container. So now here, when the pieces are when the application is divided into pieces, then how the one piece is going to connect to the other piece. Right? As an example, right, when I'm trying to purchase any item through the e-commerce portal, right? So now here my module is electronics, and it is going to when I click on the purchase, then it is going to connect to the DB module backend for the authentication, authorization, something like that. Right. So now this electronic module has to send or has to communicate the payment module. Right. Or from the electronics, I want to move to the clothing side. Right. Right. So now here I'm going to click on the clothes as an example. Now this electronics to clothing side. Like that, the services communication between the communication between the services inside the cluster. Then how these services are going to call the DBs. So that we'll have a better understanding how these applications are going to deploy into the Kubernetes. Okay. So for that, I will show you my project, how we are handling here. So let me. One sec. Development environment, the cluster. So now I'm trying to search for the parts. kubectl get parts. Right, some huge amount of parts are showing here. So these are the parts, nothing but our backend APIs. Now here our application structure is something like this. We have total 3 layers. And the 3 layers, one is front end, and the second one is back end. This is front end GUI, and this is back end APIs, and this is again back end DBs. So now our application is something like this. 3 layers. One is the front end, the GUI part, so for the end users like you and me, and this is nothing but the logic, backend APIs. And what I'm trying to go through the application, these logics are going to execute on the backend APIs. And any data, right? Data related thing will be under the DBs. So now here everything is a service, microservice here. So it's not as a single application is deployed into the server. Instead of separate containers are deployed for this application as individual services. So now here you can see these are nothing but now these services are nothing but this section, backend APIs. So now in our application there is a communication services, their exchange is their identity for the authentication, some loyalty programs, member programs, permission, something like that, based on the application, whatever it may be the services. We are not going to bother about it. So now here we have, if you take here, we have around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 services are there. This is separate setup, help setup, this is separate. You can consider only these 12 APIs are there, backend APIs. These are nothing but the part of the application. So now these guys will receive the instructions or the request from the front end. Then these guys will talk one and each other, like the communication may talk with exchange, the exchange can maybe communicate with the members, like that, based on the application process. These services can communicate one to each other, or these services can talk with the DBs. Right? So now here the probability will be either the APIs can talk one and each other, or these APIs are going to communicate with the DBs. Right? So now here these are all the individual containers. Right. So now here when the individual containers, how this campaign is going to communicate the communication, or how the scheduler is going to communicate with the loyalty, like that, right? The communication has to be established, and also like that, how these services are going to communicate with the DBs. This is the important area for us. Actually, the communication is a very, very important area. Let's further that. So now here at, at present we are seeing the APIs. So now here I am trying to show you the DBs. Now if you observe, you should be able to understand what I'm trying to do here. Right? -n, nothing but namespace. Right? So these services are deployed into separate namespace, and the DBs are deployed into a separate namespace called Braille Corner DB. As per the architecture, this is not like every application must and should deployed into separate namespaces for the services. No, it's not like that. Based on the architecture, like how the architecture was designed, based on that we are going to implement it. Right. So now here in our architecture, where we have placed the DBs in a separate namespace. So now we can observe here campaign. This is the API, and for the API, this is the DB. Communication. This is the API for the communication. This is the DB. Likewise, for each service, we have a separate DBs, micro DBs we are going to call. Instead of a single DB, we are going to have a separate DBs for the each service, micro DBs, members, permission. Like that. Now here, what we have done here is we have created the pods, right? Now the pods are nothing but the containers. We have created the pods for the DBs, and we have created the pods for the backend APIs. This is the setup. So now here, now the concept is how this DB got deployed. Right. Here we need to understand some more concepts here when it comes to the DBs. Right. So usually we know, suppose this is my cluster and this is my pod. Pod means you can treat it as a container. So now here containers are stateless. Right. So whatever the data we are injecting into the pods, those will be there until unless this pod is alive. If the pod is gone, then we are going to lose the data because the behavior of the container is stateless. Right. So to maintain the persistency, correct, to maintain the data, for that what we are doing in the Docker side, we are creating the volumes. Correct. In the Docker, we have created the volumes, and these volumes are mounted. These volumes are mounted to the container. Right. So now in our Kubernetes architecture, we are not going to mount the volumes straight away, something like this. This is the structure for the container. We cannot mount something like that. So now here there is a process which we need to follow to mount the volumes to the pods. Here the we are mounting to the pods, not to the containers. In the Kubernetes architecture, the mounting of means the persistence of data will be on the pod side, not on the container side. So now here this is the cluster, then in the cluster this is the my pod, right? We know a pod can have a single container or it can hold multiple containers, right? But usually the best practice, we are taking only one container pod, but yes, we can have multiple pods also. Then whatever the volumes we are creating here, right? So now these volumes are going to consume by the containers, but straight away we cannot give because there is a pod in between. There is a pod in between, right? Between the containers and the volume. So now we are going to connect to the pod. Volumes are going to connect to the pods. Now these containers are connected to the pod. These containers are connected to the pod, like whatever we have mounted here. Like there is a layer now. So the layer is nothing but the pod. So right earlier directly we have the container and we have the volume directly we have mounted it. But here we are connected. We are mounting our volumes to the pod level. Now from the pod, these containers are going to consume. This is what the architecture for the volumes maintenance, volumes mounting into the Kubernetes cluster so that you can maintain the data. Right. So for that, what we need to do? Right. For that, what we need to do here, we need to create persistent volume first. After that, we need to create persistent volume claim. Persistent volume has to be claimed. Then use it. Then if you want to retain or reclaim or refresh, whatever, remove or whatever after that. Right. So now here, these are the steps which we need to follow. If you want to mount, if you want to maintain the data, persistency, there we have to follow, we have to create a persistent volume first, and after that we need to claim that volume, then after that use it. Right. So what exactly these are? So usually this Kubernetes is going to support multiple clouds on premise. Number of components is going to support, right? So let me take to the persistent volumes in Kubernetes. Right. So now here managing the storage, right? So for that we are in the persistent volume, we are going to call it PVs. Persistent volume claim, we are going to call it a PVC short form. PVs are the volume plugins. Now these will be the plugins. Right? By default, your Kubernetes not having the feature of this volume management by default. So now when you want to utilize these concepts, the volume management, then the respective plugins has to be installed. PVs are the volume plugin. Right? So like volume. So right, so why the plugins? What is the reason? Right? So because your cluster may be created on AWS cloud or on Azure cloud or on Google cloud or any whatever called virtual machines or on physical servers. Right? There is a chance we can have the cluster on any kind of platform. So now these clusters has to maintain the data. Right. So now here as an example, my right now my cluster is created on the AWS. On the AWS. So now here I want to maintain the data. Now on the AWS, we have a separate services there, which will not belongs to the cluster to maintain the storage. So now that storage service I'm going to use so that I can maintain the data of my system. Right. So now when the service is different, which will not belong to the cluster, but you want to utilize it, you want to use that service. So there the plugins comes into picture, right? Like our Jenkins, right? By default, Jenkins is not going to support anything. When you want to use any particular services or tools, we are taking the plugins so that your Jenkins is able to communicate with that plugin tools. Like the same thing here also. Right, so now here, the cluster which you want to use, that cluster requires the database support, means the cluster requires the storage support. So now the storage can be anything, like it can be a hard disk, it can be a volumes of AWS, or it can be a files of Azure, something like that, anything. So now when you want to use that particular component on your cluster, just to require to install the plugins. That's where this concept they came up with the plugins. So now here, what kind of plugins are going to support here? As I said, see, retain, recycle, reclaiming. This is the part of storage protection. Reclaiming, retain, delete, recycle. That is the life cycle. See here, extending persistent volume claims. These are the volume claims. So let me go to the persistent volumes plugin first. These are the types of the persistent volume. Persistent volume types are implemented as a plugins. Kubernetes can support the following, right? So you can it is supporting GC, Google Cloud, AWS, Elastic Block Storage. This is what the service. Right? AWS is having separate service to maintain the data, nothing but the EBS, Elastic Block Storage, Azure Files, Azure Disks, CSIs, like many things, many FSIs, NFS. Right? So the only the thing is when you want to use anything, suppose I want to use vSphere volumes, so that I want to store the data into that volume. Just you require to install the plugin of the vSphere volume. That's it. That's, so it kind of like so then you can write a files the manifest file to utilize it. I will show you how to set up that one. Right. So now here, like based on the requirement, we are going to take the respective plugins. Right? Again, it will be your architecture role. Those guys will be decided which one has to be used to maintain the persistency, which plugin. Right. Okay. So now here, let me go to our part. So now here, this is the AWS and AWS service, cloud service we are using. So our clusters are running on the AWS. So now here we have a service called EBS, Elastic Block Storage. Right, so here EBS, Elastic Block Storage, you can see. So this service is nothing but it's going to maintain the hard disks. Elastic Block Storage is nothing but the hard disk. So now here in the hard disk side, you can see a volume. In the AWS terminology, those that is hard disks are going to call as a volume. So now here, these are the volume. Means we have created the hard disk. Like see, you can see 200 GB, 500 GB, something like that. Right. So now here in our AWS, the service is called Elastic Block Storage, nothing but the hard disk. So now here, this storage we would like to use in our Kubernetes cluster so that my database, whatever the data is pumping into the pods, that will be stored inside this particular EPS volume. Right. So then how to create this persistent volume and claim then how to use that volumes into my application. So for that, what we have done here is we have created for each service, we have created a separate folder. Now these are the nothing but the databases. For each database, we have created a separate folder. Suppose if I go to some member. So now here we have seen deployment kind, pod, deploy kind as a pod, service as a kind as a service, right? Different components we have seen. So now here this is the one more component called persist, persistent volume. So now here the persistent volumes are nothing but how much storage you are looking for. Okay. So now here we have the hard disk space of like 200 GB, 50 GB, right? So we are going to create a hard disk, nothing but a volume with some size. Suppose I have created some size of 200 GB. So now here this 200 GB I want to utilize it, right? So how we are going to utilize? So here I have these many services are there, like campaign, communication, identity, right? Each module is a separate server now. Right now here in my application there are around 10 to 11 services out there. For each service there is a separate DB, micro DB. So now here I would like to use the 200 GB to my all of the services, backend services to my DBs. Right? Suppose these are assume 10 services are there, then I'm going to utilize 10 into 20 so that it will become 200. Right. So now here how much size, how who will decide again, right? So one thing, either your architects or first will go with some limitation like 20 GB or 30 GB, something like that, right? So then once it's beyond 20 GB at some point after, then we are going to increase it because it is in our hand, simple, right? This is a service. We are not taking any physical hard disk. It is service of AWS. Advantages here is you don't require to do any kind of maintenance. Just your job is to require the resources and pay the rent. So now here 20 GB is not sufficient. Then I will require for 300 GB. Just a instruction has to pass. Now they are going to give the 300 GB. Just I need to pay the rent for the extra 100 GB also. That's it. Right. So now it's not a big deal for us increasing the limit. Right. So now here either go with some limitation, then go for, then once the limitation is reached, then you can extend it, or based on your architecture. Right. This architecture is saying like yes, for the each service you have to take minimum something like some G. So then here once the EBS is ready, then this EBS we are going to use in our services. So now for that we are going to create here the persistent volumes. So now in the persistent volumes, this is the version, API version, right? So now this is the metadata, nothing but the identification of these particular volumes. Now here I'm going to use this persistent volume for the members, another service. So under the specification, on the spec, how much storage you want to utilize out of the 200 GB, right? Out of 200 GB, how much storage you want to utilize. That's what we are going to tell in the storage section. So now here on the hard disk, what kind of operations you want to perform, you are going to perform, right? Basically, what kind of operation you are going to perform on the DB side, you are going to fetch the data or you are going to write the data, read and write, right? So here I'm going to say read write once. Right? So then this is nothing but our volumes mounting point. Right, right. So now here this hard disk, nothing but the volumes, right? Where you are going to use, right? That's simple concept case here. So now here, now this is my AWS instance, nothing but the server, right? AWS server. So now this server is going to attach with some EBS volume, elastic block storage, some 200 GB. Right. So now if you guys observe, when the moment we are going to create any missions, by default 8 GB of storage hard disk they are going to allocate. So what is this here? It's EBS. This is EBS volume. Right? This is the default stuff. So now here we have created upfront a hard disk space of something like that. Not with the system, just with the create volume. You will see in our AWS class. Just create volume, then have created a hard disk upfront, not with the system, like 200 GB, 300 GB, something like that. Now this EBS I want to use it. And so now here, what we are going to do here is simple. So whatever the volumes we have taken, that volume we are going to mount with your AWS instance. Right. So now here, whatever the data I'm pumping into the instance, it will be go to the my EBS volume, like your Docker volume, same concept, no difference. But only the thing is, which data you want to take it, right? Because you will be having in your server, like you will be having OPT drive, like you will be having ETC drive, like you will be having some other local, something like many locations will be there, right? So now which data you want to push to the storage, right? OPT ETC are not required for me. I require the data of nothing but the data drive. Whatever the data is coming into the data folder directly, that data I want to store it. This was the main data. So now what I will do, so simple, we are going to tell push the data slash d data to the EBS volume. That's it. Right. Right. Again, if you remember the same Docker concept, correct? So now here in the server, which location data, which path you want to mount it to the ABS, so that the particular path of the data will be stored in the ABS. Docker concept. Right. So now here, this is what. So we have a separate space called ABS. This space I want to use in my server. So when you want to use in your server, then you are going to tell which path, which drive data you want to store. So now this is what we are going to call as a mounting. Right. So now here, if you guys observe here, we are going to tell host path nothing but mount member, some location we are given. Right. So now here, this server will be having a location called mount members. Now this mount members is pointed to my EBS. So out of 200 GB, I am expecting of 5 GB. I need 5 GB. That's it. Right. So likewise, because here, if I take the cluster now, this is my master, and this is the slave one, and this is the slave two. Correct. So now here, this is my EBS volume with a separate service, and this is my master, and this is my slave one, and this is the slave two. Right. So now here, this EBS volumes I want to use in my cluster, my Kubernetes cluster, so that whatever the data, right, same story, data will be stored in the EBS volumes. Right. So now here you are going to tell, right, I'm going to tell this is my location. Mount members is the location. Right, we know master is not going to take any load. It's just the master job is to management job. So now load will be taken care by slave one and slave two. So now here I am going to tell in my slave one, I am going to have a directory called members. So now here whatever the data is coming into the members, that should be stored into my EBS volume. This is what I'm telling here, right? Because there are three machines are there. Out of three machines, which machine you are going to use to store the data? Right. So I have taken the slave one. Now in the slave one, I'm going to create a path called mount members. We are going to create it. If you are not created, by default, your persistent volume is going to create. Either create from your end, go to the location, create a mkdir member. Simple. That's it. It's a directory. That's it. So now here, create a directory, or automatically your volume will be created if you don't mention, if you don't create it upfront, right? So now here, this is fine. Now here, I know like there is EBS services there, and this EBS service I am going to utilize in my cluster. So now here, out of the cluster, there are three servers are there. Out of the three servers, this machine I'm going to take it to store the members data, a one service data. Now, how the cluster will know this slave machine only is going to use for the members? Correct. That's what we are going to point the IP address here. So now here I'm going to tell this is the location. This is the location where the data is going to store. On which mission? Slave mission. Now how the cluster will go to understand this is slave one mission. So the server of the IP. Right. So this is what the node affinities we are going to call. Node affinities are nothing but we are going to write the roles. Go to deploy into this particular server. Go to connect to the particular server. Node affinity, anti-affinities. Anti means don't deploy into the server. Affinity means deploy into the server. Right. So node affinity here we are required node selector times So now here we are going to match the expression. Which expression you are going to try to? You are going to try to match with the host name. So now the host name in, though the operators are nothing but there are the certain operators are in, equal to, not equal, something like that. So now the host name in this IP, this uh, IP address of the server. Then if it is matches, then go and deploy the mount members, go and connect to the mount members for the 5G. Right. So now here this is a concept called node affinities. Now if I give anti-affinity, then it is not going to deploy into the server. It is not going to go deploy into the server. Right. So now here persistent volumes are nothing but we are going to looking for the size, the volume size. We are look how much the size of the data you are looking for. So that much of size you can ask to the your plugins, volume plugins, like it can be EBS or some XYZ. So you can ask the plugins like I need this much of data. Sorry, this much of size of the hard disk. That's for the storage. Then what kind of mode you want to use? Like you want to only use for the read only or write only or read and write, like that. Then right. So on the server, where is the location of the data, like where the data is going to store, what is the location of the storing point of the data. So then there is a concept called node affinities in our cluster, nothing but which server you are going to target. Right. So now here we have got the 5 GB of space, 5 GB of space from the EBS storage. Out of 200 GB, suppose there is a 200 GB, then I got the 5 GB of space. Right. So now here this 5 GB of space I am going to utilize for the members. Still I have a 195, suppose it's a 200 GB size, still I have 195 GB of space is still left. Right. So now this 5 GB I have asked, like I have asked the EBS volumes, like I want the 5 GB, then this 5 GB I want to use into the this particular mount members path of this particular slave one mission. That's what I have mentioned the persistent volume. Then who is going to use it? Right, I have created some kind of box, a space box on the cluster. So now who is going to use? The member service has to be used, the member DB service has to be used. Here just we have taken some space, that's it, we have taken a space. Now this space is going to use by whom? The member service. That's what the persistent volume claiming. Right. So whatever the space you are taken, now the space are going to claim by someone. Who is the guy? The service. Here the members is the service. Who is that guy is going to claim the data, the space, the data, sorry, not the data, space, the 5 GB space. So that's what here we have one more service module called persistent volume claims. Right. So now here what you are going to mention in the persistent volume claim. So simple here, how much space you have taken, right, into the from the space, how much you want to claim it. Suppose I have taken for the members of 10 GB of space in the PV. Now I would like to claim only 5 GB. I don't need the 10 GB right now. Later on if required, I'm going to claim the other GB, like the rest of the part. Otherwise I will good with the 5 GB. But safe side, I have taken the 10 GB, like that. Like that, you can take the space. Out of the space you can claim whatever you want. That's what the persistent volume claim. So now here usually how much you have taken, that much we are going to claim it. Right. Now the access modes. Right. The other, like once you have taken the claim, like the data space, then on the space what kind of operations you want to perform. And this is nothing but the metadata is nothing but again our identification of the persistent volume claim code and DB. Right. Now my persistent volume name will be the same and the claim name will be the same, so that it is going to match. If you are giving some different name, then there is a chance of mismatch, and these volumes are not going to allocate to the persistent volumes. Better to have a common name. So now here the 5 GB is resource requiring, then here this is the concept selector. Right, who is going to select here? So my app I am going to select. So what is the app here? Corner DB members. So now here Corner DB members I am going to map it. One second, please. Right. So now here the 5 GB of space I want to claim it from the persistent volume. and the match label, right? Which one you are going to match? I'm going to match with the persistent volume DB members. So now both will be joined. Both will be joined with both will be communicated, right? So now here volume is created and the volume is claimed. Now who is going to use, right? Once the volumes are ready, then who is going to use the nothing but our services. So now here my intention is I want to use for this service. So now here we'll go to the service section, here deployment file. Now we know a deployment file will be having the service, right? This is not the default of the deployment. It's a separate module service. But you know, right? We can have separate files for the deployment and the service, or we can club together. We can have only one file. That file will be taken care of the service deployment as well as the deployment also. Right? We have clubbed together. So now here this is the part of my service and this is the part of the deployment. Right? So now here I am trying to create a ConaDB members service, ConaDB member service, and this service I want to connect with the node port. Right? We know what is the node port here, right? So what the purpose of the node port is, you can access this service from the outer world. Right. So right, so now here a static port number we have given something like 3050, some random number. My selector name is app name I have given as a member, so that I'm going to use this app name inside my deployment. Right. So simple service, and the service type is node port, and the node port we have taken something, and the app name we have given. So now this is the main part, right? Deployment. So now in the deployment, how many copies you are looking for? Replicas, right? One. And here the label name is the same name we have taken, so that is going to match. Then in the spec part, in the container section, image we have taken as the Postgres, the DB, right? Because your DBs can be a Postgres DBs or MySQL or Oracle, whatever it may be. Like in the Docker, when it comes to Docker, simply we are going to take the respective images. If I want to work with the MySQL DB, simply are going to take the MySQL image. That's it. So then in the MySQL, once you take in the MySQL image, the MySQL container is going to create. Then do the configuration, right? Right. Your application has to communicate with that MySQL container, the DB. That then the proper configuration has to be done. That's it. Your application go and talk with your DBs. Like that here in our project we are using the Postgres SQL DBs. So now here simply I have taken the community image. This is not the custom image. Whatever the image is available from the community, we have taken it. Postgres 10.4 version, I have taken it. So now it's going to create a container for us with this image. Now this is the port number of the Postgres SQL 5432, right? So that you can connect to the database by using the port numbers. Then environment from. So nothing but creating the environment variables. Right. So what is the environment variables we are going to create? We are going to create the environment variables of my Postgres DB details. Right. So usually if you want to connect any DBs, you require the database name, you require the username, you require the password name, so that you are going to connect with these credentials or with this login information, right? So I want to connect to my Postgres SQL. Then what I'm going to do, I will take the Postgres DB server name or the IP name and the Postgres DB port number, right? So my Postgres DB server name is suppose postgres.com, then 5432, then database, which database you want to connect, then the username and the password, so that you are going to connect to that particular DB. Right. So now here, where this information you are passing to your Postgres DB container, that's what the environment section. We are passing this connectivity string details, nothing but the username, password, host number, IP address, port number, everything we are going to pass to the environment section. So now in our cluster, like Docker -env, we have used it, right? We have used the env section, nothing but environment variables configuration. So in our cluster, the same section can be done with the help of env from nothing but this is the section, the deployment manifest file. So config maps, we are going to call as a config maps. In our cluster, there is one more section called config maps. So with the help of the config maps, you can inject the environment variables to the containers, right? Or you can say the pods. In the pods, the containers are going to running, right? So now you can inject the environment variables to the pods with the help of config maps. There is a section called config maps. So simple, it's not a big deal here. Simply, we are going to create a file, config map file. That config map file we are going to pass to the deployment object as an input, so that when the deployment object is going to launch, it will try to create a replicas of this Postgres container, nothing but the pod. When the pod is going to create, so in the pod, it is going to inject the environment variables from the config maps. This is what the section config map reference. Means reference. So which one you are referring? I am referring Kona DB members. This is my config map. I will show you. So now this map is going to have the all the environment variables. That's it. So now this is nothing but the deployment section until this. So now volumes mounting, right? So now here your pod has to be connect to the your persistent volumes, right? Your pod has to be connected to the persistent volume, right? So this is what the section here. So now here if you guys observe volume mounts, right? So now your container, your pod is has to be connected to the volumes. Now these volumes are nothing but my persistent volumes. That's what the link. So now here I am going to tell which one you want to mount it, right? Where the data is going to produce in the pods, where the data is going to produce. So in the pod, right? So here this is my pod now, my container, right? So this pod will be having Postgres SQL container. Right? Inside the pod, where the data will be stored, right? That's what this one, where live Postgres SQL data. Right? So inside the pod, data slash data, as I'm going to give something else. So slash data means value, right? So inside the pod, the data will be means the database, the records will be stored in the slash data folder directory. Now this data has to be connected with your members of the this particular slave machine. See the link, guys. Now you will be having a separate server called container. In the container, you are going to have a path where the data is going to store, nothing but the some slash data, something like this. Now this slash data is going to mount with the slave machine. Whatever the slave machine I have there, the server instance. On the slave machine, I have chosen a particular location called mount members. Some location I have taken it. Right? You can take it any location. So now this data will be stored inside the mount members. So now this is not the permanent. Correct? This is not the permanent. So if I lose my slave machine, I'm going to lose this data. If I lose my container, I'm going to lose the data, right? If I lose the container, I'm going to lose the data. So now to maintain the persistent, what I did, I have mounted my slash data to my slave machine, one of the location. So now here, even if I lose the data, sorry, I lose the container or the pod, still I can have the data. I can create one more container, I can mount it. But if I lose the slave machine, now I'm going to lose it, the data also. For that, this EBS volume. Even if I lose the slave machine, still I can have the data. Then simply I can take this data and I can mount it to some other server. Right. So likewise, this is the link. The link is going to establish likewise. So now here we are going to tell volume of nothing but whatever the container, whatever the pod we are going to create. In the pod, whatever the location the data will be stored, the location we are going to mount it with the our slave machine mount point. This is what. So now here I am going to tell take the path and mount to Kona DB members. Right? I am not saying like go mount to mount members. I am not saying that this one. I'm saying like mount the slash data to the Kona DB members. So what is a Kona DB members here? So that's what the volumes. This is mounting from the container from the part to your storage point, nothing but your volumes. So now here the volumes information will be something here. So now what is the volume information here? So now here this is what I'm telling, like just go take this and mount it. So this information I'm going to tell here. So in the volumes, this is the name, Kona DB members, claim name. What is the claim here? Persistent volume claim. So I'm going to tell connect to the persistent volume claims, DB members. So now here, if I go to the PV, now what are the persistent volume claim members here? It's the DB members. What are the DB members? Nothing but the main storage point. On the server, into this location, I have the total 5 GB space. This was the link actually, right? So that is what the persistent volume claims and our what is called volume mounting, right? Then the config maps, right? So now here, right guys, so this is how we are going to mount the volumes into the cluster. It can be a database mounting or some XYZ mounting, what it may be. The thing is, you require the persistent volumes, then the volume has to be claimed by using the PVC persistent volume claims. Then the persistent volume claims you are going to utilize in the deployment object, the link, right? So now here, let me open the config map. Right here, we are referring the config maps. So let me open the config map, my environment variables, DB members. And so open, this is the config map we have created. If I open the config map, this is DB members. My config map name is the DB members. Yes, that is what the name. So simple, what I have mentioned here, my database is members and my username is members admin and the password is member something. Right. So now these are the my authentication details, so that the application is going to utilize this environment variables. Environment variables are going to utilize the application, and the application will be connected with the database. Okay, I will show you that part also. Right. So now here, usually that database should not be exposed into the outer world, but here we are exposing into the outer world actually. It should not be like that, right? Because it's a private actually. But the thing is, right now we are in the implementation phase, so now we are facing some issues with that, right? Sometimes the data is not properly uploading, sometimes the records are not updating properly. So by that time, the DB, whoever the guys are there from the DB side, they want to see, they want to connect to the database and they want to see the data, how the data is updating inside the database, and the properly the data is pushing the not for the verification purpose. So now for that reason, we have taken the node port so that you can connect to the application. Otherwise, we should not expose the DBs into the world. Okay. So this is not the mandatory one. This is intentionally we have exposed because the DBs want to have the connectivity to the database to verify some statistics information. So now here is admin. This is a tool for the Postgres database management tool, so that you can with the GUI. With the GUI, you can manage the databases of the Postgres. PGAdmin is a tool. So just I want to show you how we can connect to the databases. Some name I have given and then the connection string. Post name has to be entered. So here node port, right? Node port means you can connect to any instance of the cluster. You can take the slave missions or you can take the master mission or anything. So here I have taken the outside the port 5432 is the Postgres DB port number. I have shown you there, and this is the database, and this is the username, and this is the password. So this information we are injecting to the config maps, and this is my database, and this is my username, and this is my password. 5432 is not accepting. Okay, fine. So this is the port number which I should have for that is internally. That is inside the container port number. Right. So I have exposed the port number with the node port, right? So we have to pass the exposed port number 30503. Node port has to be used, right? So not the 1 second, please. See, the dev members means this is the server name I have created. If I expand it, there you can see database with the name called members. Where you can see this information, you can see the information in the config map. For this is the one, right? Members. What DB I have given, the database members is created. So inside the database members, you can see the tables. These are all my tables. For the members service, these many tables are there. This is not our duty, creation of tables and other stuff. Our duty is to create the database, and provide some credentials, authentication, and launch as a pod inside the cluster. Then the developers will be taken care of creating the tables, using the database, means using the tables, whatever they want to do, they are going to take it care. Right? These many tables are there. This is as part of my application. That's it. Based on the application, you'll be saying hundreds of tables also. That is not a big deal for us. That is not our duty also, right? So now here, now you can understand here, we have launched the DB inside the cluster for each service. Right? Just now we have verified these members. Likewise, for each service, what we have done here is we have taken separate folders. So now here if I go to the redemptions, CD redemptions, just a replicas, that's it. So now here you can see the deployment file, volume file, config map. If I open the volume file, everything is the same. The only difference is earlier it was the members, now we have replaced with the redemptions. Members is replaced with the redemptions. Then the host, where on which mission you want to launch, right? Because we have the two missions on this mission or on this mission. That one that is up to us, right? Because five total 10 are there. What we did, five we are deployed to the slave one and five we are deployed to the slave two. So that is the reason you are going to see some other IP number here. So now here this is the mount point. We have taken the redemptions. Right. So now again, the rest of the things are the same, no difference. Just you have changed the members to redemptions, and this is also then IP. Right. As I said, five are deployed into slave one and five are deployed to slave two. So we are taking this one on some other slave mission. That's it. Then the config map. In the config map, the environment variables are nothing but the credentials. We can see here, right? So what we have done here is just taken the database name, some username and some password. Default username and default password, so that the application can utilize this default username and password to connect to the databases. The application can connect, or the administrator can connect like this, right, with the GA. Right. So now here, right. So now the backend, from the backend section, the DBs are deployed with the help of config maps, with the help of persistent volume, with the help of persistent volume claims. These are the components we have used it. So now the DBs are ready. Backend DBs are ready. So now here my APIs, the logics. My APIs has to be communicated with my backend DBs. These guys. Now this is the API. This is not the DB. Now this API has to connect with the DB. Right. So who is going to take care? Not by DevOps. Not by the DevOps. Not the DevOps duty is to connect the backend APIs to the DBs. We are going to provide the DBs. We are going to provide the authentication details to the developers. So now whatever the code they are going to implement, like members is a service, right? They are going to deploy, they are going to write the code for the member service, member module. So now in the code, from the code, they are going to call the connectivity string to the DBs based on the requirement. Now, how that connectivity string details they are going to take, we are going to provide. These communication details we are going to provide to the people, to the developers. Now they are going to consume these connectivity string, nothing but the properties, and they are going to use in the application. Like how? Like how? Right. So guys, this is for the understanding, so that you will be having a good picture of how this application will be running inside the cluster, how the services are going to communicate one with each other. Usually if you learn critically, you will not see in this kind of area actually. Right. So now here I will go to one of the service, right? So like let me go to members only, because we have seen the members, right? I will open the member service repository. Right. For each service, for each backend API services, we have taken a separate repositories. You can see here loyalty configurations. So now here you can see loyalty configurations, right? For the loyalty configurations, for this API, you have separate repository. Likewise, for each service, we have separate repository. That is again on the architecture. It's not like it's a mandatory one for each and every project has to follow. No, based on the architecture. So now here you can have a single repository, you can place all together, or you can have multiple repositories. Because it's a microservice world, better to have a separate copies, separate repository, so that easily it can be maintained easily. If you club together, it will become a monolithic. So now here members. So now here, if I go to the members, I will go to the develop branch. So then this is the .NET project, .NET code. So here I have a file called folder called API, and here I have, this is the launch file for the .NET projects. The launch file will be the startup.cs file. Usually the default launch file will be the startup.cs. So now here I will go to the startup.cs file. Then here I will check for connectivity. Connected string original. Right, so here you can see this is the connection string for the member DB connection. Right, you can observe here member DB connection. So in the code they have, right, in the application, like the member service application, they have implemented a code of nothing but the connectivity of DB. Right, what exactly this is it? Again, connection string members DB. Right. So here this is nothing but this particular service wants to connect with the DB. This service wants to connect with the DB. Right now, this service has to know this DB details. Then only this service can connect to the DB. Right. So where this information will be getting by this particular service, where this information can be found by this service, how this information will be, right? So who is going to provide that information? Which information? the connectivity information. For what? The DB. That's right. Again, that is, we have taken the environment variable section again. Right. So once wherever that particular service will be launching, now in the service we are injecting the environment variables. Now the variable is nothing but my DB connection string also. So now what? Now when the people are going to use, people means the developers. When the developers are going to connect, or they want to connect to the DB from their module, which one? Members module, from the service, from the member module. If they want to connect to the DB, so already we have provided the DB connectivity string in the form of environment variables. Then what they will do, with the help of the code, they will call the environment variable. That's it. So now the environment variable will be having the authentication details. That's it. Now once they pick the environment variable, it is having the connectivity string. Simple, they are going to use it. It's going to connect to the DB. Like how the Postgres DB is going to connect to the database with the DB name and username and password, right? So what we did here is we have injected the connectivity string, nothing but here the username and password, into the DB, Postgres DB. So right, so now inside the DB I have the my connectivity string details. So what I did here, I have used the same details to connect the DB, because those are the part of the server. The environment variables are the part of the server. So I'm going to use the server variables only. Like how we are going to pass the variables into the server, those are nothing but the environment variables. We know, right? We have seen the environment variable section many times. So now what I'm going to do here is, from the service also, now my member service, my backend API want to connect to the DB. Right. So now my member service, when the member service want to connect to the DB, in the member service, right? Because the member service also a separate server, a separate container, member service also. Now inside the container also, what we have done, we have injected the connectivity string of the DB details. So now the application will going to call the environment variables of the particular server, then it's going to connect the DB. Right. So now where we have configured it, this connectivity string details. Which connectivity? The DB connectivity. So that is again the config map. Yeah, so let me open the config map also here. So now here inside the repo in the develop branch, along with the code, along with the development code, we have placed the config maps also. Right, this config map for the that particular member service config map, backend APIs, not to the DBs. Right. So now here some API name. The config name we have taken as a member API. Earlier Kona member DB. Now here it is a API. Some name. So now this is the connect string member variable name, environment variable name. So now I'm going to copy this variable name and I will go to the startup.cs file, then find for it. See the same name. Right. So now here the concept is simple. Right. So inside the container now. Right. So now this is my pod. This is my pod. So inside the pod, we are going to inject the environment variables, connectivity, string, username, password, something like that. So now these will be a part of the server as an environment variable. So now whoever wants to connect to the DB, right? So now this is my service API. Now this is my DB. Whoever wants to connect to the DB, right? So now here I'm going to use the details. These details are for what? These details are for the this particular DB connectivity string. That's it. Right. So now here for that connect string members connection variable name we have created. Then what DevOps job here is we have created this DB with the so and so credentials, DB name, username, password. So now the DevOps job is whatever the environment variable you have created for the connectivity of the DB, this variable name has to be provided to the developers, because developers won't know, even they don't know what exactly this variable. We need to tell it. We need to tell them, guys, this is the environment variable which we have created to connect to the member DB. So now in your code, use this environment variable to connect to the member database. That's it. So now this data has to be provided to the developers by the DevOps. So now they in their code they have used this variable. That's it. Deal done. Now from that application, the connectivity to the DBs will be happen to this environment variables. Like how this is established. This is the process. Right. So now here this is one thing. Right. In our story, this is one thing. Let me explain the story again. Now this is how my application is. Right, front end. Our front end will be there, GA will be there, will be connected to the application with the help of this front end. And right, whatever the operations they are going to perform, it will go to the backend APIs, logics. So now right, there are different modules are there. Like I have taken 3 as an example: members, communication, identity. Right. So what are the operations they are performing for the members, like creating a member in my application? User creation. You can take it as user creation of members, managing the members, something like that. So now here the members data, right? The data has to be stored in the database. Now for each service, we have created a separate DB, micro DBs, member DB. Okay. So now this guy will be connected to the member DB, right? With the help of our environment variables. Right. So now here this guy will be connected to the member DB with the help of environment variable. Who is going to provide these variables? DevOps. Right. So DevOps folks are going to create the environment variables, nothing but this thing. Now this is nothing but connectivity data. Suppose an example I have taken here the host, nothing but the where the database is running, the server details, and the username. Right, these are the username I have taken from the config map. In the config map I created for the DB, username is member admin, password masked out. It's a separate segment. Corner member something the password and the database name is members, and the port is nothing but the inside the container port, not the node port. Node port will be to connect from the outer world. Internally to the container should be the internal port number 5432. So this is what the variable which I have created, and this is the connectivity string I have passed it. So now the people, the developers, don't require all the details. They don't need to pass everything here. Simply they can take this variable. This is what the DevOps duty. Yeah. So now this is fine. So now my services are going to connect to the respective databases, which we have done. This is one communication, APIs to DB. Now the other communication is I want to connect to the members to communication. Right? Or I want to connect to the members to DB, sorry, identity. Or I want to connect to from the communication to identity, right? Right? These services have to communicate with each other. Until we have seen the communication between the APIs to DBs. So now between the services communication, right? How we are going to do? Same story. Again, the environment variables, the config maps. In the config map, whatever the other services which this particular service want to communicate, right? So now here my particular service is members. This guy wants to communicate with the loyalty. This guy wants to communicate with the transaction, stores and products, communication, redemption, identity, like that, right? So whatever the services which this guy wants to connect, again, those services are also created as a environment variables. For each service, we have created a separate environment variable, communication, right? So now here, this guy, members wants to connect to the communication, right? For that, what we have done here is, inside the members container, we have created environment variable with the name called communication something, communication API, some name, some unique name. So now here, this variable will be holding what? This variable will be holding the connectivity details of the particular communication service container. Container means the pod, right? So here now, this guy, now here there are my different services. In my cluster, there are the different services running here. So now we are taking the example of member, and this is the communication, and this is member DB, and this is identity, and this is some redemptions, right? Right, because in the cluster, you are going to have your database containers, you are going to have the APIs container, everything will be the same cluster, right? So now this member wants to connect to the DB, right? That is what here, connection string of member DB connection. So in the code, they are going to utilize this variable so that it will be connected to the database member DB. And now this guy wants to connect with the communication, right? So now how this communication is going to happen between the member service to communication service? For that, a separate variable. Right. What is this variable here? Nothing but this container information only, right? This container server details only. Right here, this is the server details. I will let you know. That's it. So now here, when they are trying to use this code, maybe not in the startup file. Startup file is nothing but the loading file. In the background, in the logic, somewhere this variable are going to use. Right? It's not the complete application. It's a simple startup file. Right? In the background, somewhere they are going to use. Right? Wherever they are going to use, we are not going to bother about it because our job is not that one. Our job is to provide the correct details. Right? So now here, when the service wants to connect with other services, those service details also we have passed to the environment variables like this. So now what is this? This is nothing but your server, nothing but the container, nothing but the pod. At the end, it's the pod. The pod domain name. You can call it the pod domain name to connect it. Right. So how the pod domain name will be identified? Right. Simple. So the first section will be the your deployment name of the particular service. Deployment name of the particular service. Right. So now here, kubectl get deploy, right? To see the deployment details, deploy is the option. Now here you can see communication. Right, this is what priorly communication API is the name we have given. Names are our wish. There is no separate policies, right? We can give any name. So we have given the name of priorly communication API something, right? So that's what here. Now the first section will be, right? So you can see here the separation with the dot. Right, the first step will be nothing but your deployment name of the particular service. Now this is the communication service name is the Braille communication. Then followed by namespace. Followed by the namespace. Right, because your cluster will be having bunch of namespaces. kubectl get ns. Right, ns is nothing but the namespace details. Right, many namespaces are there. Out of that, I can see devcona, gapcona, hertzcona, ingress, kafka. Many are there. Right. So where this API got deployed. Where means on which namespace this API got deployed. That's what here Braille corner is the namespace. Right? If you want to confirm, you can confirm it. -n, right? -n, then give the namespace. Right? Correct. This service is deployed on the Braille corner namespace. Right. So now here deployment name followed by the namespace. Then SVC cluster local is the common name. Default name for any service SVC cluster local is the default name, any service wherever it may be, right? So this is what the container pod domain name, right? The identification of the, right? Likewise you need to pass, otherwise these services cannot communicate one each other. The containers are cannot communicate one, because if they are running in the both containers are running in the same namespace, that is fine. If they are running in the different namespaces, then how this guy will know this container, this pod is running in a different namespace? That is the problem we are going to face. That is the reason the name, the identification name will be given something like this. Is the format which we need to follow. Deployment name followed by the namespace name, then SVC cluster local. Right. So now let's see here. So now here this member wants to connect to the DB. This member wants to connect to member DB. Right. Now the naming convention will be member DB, right? Member DB deployment name followed by the member DB namespace name followed by the SVC cluster local. Right. So now what is the deployment name for the member DB? So kubectl get pods, because we have deployed these DBs in a separate namespace called Braille corner DB. Right. So now not the pods, I require the deployment name, right? So deployment name we are going to use. So let me take the get deploy. Right. So for the member DB, Kona DB members is the one. You can see Kona DB members. Then what is the namespace here? Braille Kona DB is the namespace. Dot Braille Kona DB. Then SVC cluster local is the common. Right. So now this is the domain name for my member DB container pod. That's it. Then these are the username and blah blah blah. Right. So likewise, any service which is running as a pod inside the cluster, if you want to connect, this is the naming format, naming convention which you need to follow. Then only the connections are going to establish. Right guys, this is how your APIs or the backend services are going to connect to the DBs, right? So how the DBs are going to create, and how the DBs are going to connect to the application, from the application to the DBs, and how this intercommunication between the services, communication between the DBs, this is the flow which we are going to follow, right? So now this is the, right, the mapping between the services. The service means it can be DB service or it can be API. Right. So now I will explain you few components, few concepts in the cluster, guys. So just try to explore the services or the components when you get the time. Okay, these are few important things. So now here we have same deployment. right? Sorry, we have seen the parts, right? We have seen the object type of the part. We have covered the deployments. We have covered the services. We have covered the config maps. We have covered the persistent volumes, and we have covered the persistent volume claims, right? And what else? Parts, deployment services, config persistent volume claims, and node affinities, right? So now here the other things are daemon sets, stateful set, and taints and tolerances, and RBAC mechanism. What else? Probes, health probes, right? So anyway, these health probes we have covered in our monitoring section, right? So now here there are some other sections are there in our cluster like daemon sets, stateful sets, something like. So now daemon sets are nothing but which are going to run in the background of the clusters, which are going to run in the background of the cluster. Daemons, right? Daemons running in the background. So now what they will do, it will always, it will, right? So daemon running in a cluster, storage daemon on every node, logs collection, monitoring, right? So now here these daemons are going to run in the background of each and every node, so that is going to capture the information of the cluster, right? So as an example, right? So you can run the storage daemon, you can run the logs collection daemon, node monitoring daemons, right? So here what this guy's duty is to run in the background and pull the information, run the background and pull the information, right? So if I go to here, kubectl get pods -n, if you guys remember or not, I have shown you the monitoring tool called wavescope monitoring tool, right? So we have covered that one. It's taking some time, but anyway, we have covered it, right? So it's a monitoring tool, the wavescope, which we have covered in our previous classes. So now here, what this guy will do when I set up the wavescope on my cluster, it is going to run a daemon agent, right? So on each and every node. That's why you can see here how many servers are there on your cluster. For those many agents are going to create agents, agent, agent, like a daemon, right? So likewise, if I go to the kubectl get pods -n cube system, you can see ODNS, right? We have discussed about the DNS also, right? In the service section, right? The service are going to match with the labels. The endpoints are going to map with the service whom by the code DNS, and also our network, our queue proxy, right? So nothing but these are the daemons which are running on each and every node, so that you're going to capture the information, right? So the best example what we can give here, you can give the queue proxies and the core DNS and the wavenets for the daemons. Right. So now here daemons and the different, usually in the interview they will ask what is the difference between deployments and daemons. Deployment versus daemon. Right. So now here Kubernetes deployments manage the stateless services running inside a cluster. Right. So now here the daemon sets are managed in a group of replicated pods. Our daemons are to the pod to pod node are useful to deploying ongoing background tasks, which are going to run in the background. They need to run in all the certain nodes, right? On all the nodes, this daemon has to be run executed, like the wavenets, proxies, core DNS, or our wave scope, like whatever you want to run in the background. And right, so now here examples of tasks, including the storage, front end, like these are the examples they are given. Let's take an example of right core DNS. This is what just now I have explained. Right, core DNS queue proxy is the one which has to be run on each and every node to catch the information. Nothing but those are the daemons. And the deployments are nothing but what are the applications, what are the services which you want to deploy. Those are nothing but our deployments. Right, what we have covered so far. Right. So that's why the deployments and daemons you can observe. You can go to the Google. You'll get more what's called. You will get the more differences. So again here, one more point in the daemon sets will be you are not going to have the replicas. I think you cannot have. You cannot launch multiple replicas like 2 replicas, 5 replicas, 3 replicas like that. The daemons for the deployments, yes, right. You can launch n number of replicas. That's what the one of the difference between the daemon sets and deployment set. Stateful daemon sets. Yeah, so usually it will be used for the monitoring and the log collections. Right? You should be running the background actually. Control that part on all the nodes. If a node is added removed from the cluster, daemon set automatically sync. So here, this is one more point from the daemon set. Right. So here, if in my cluster there are suppose there are 3 nodes are there. So now fourth node is added. Right. So now when the fourth node is added, something like that, so a new node comes to the cluster, then this on the node also my core DNS has to be the executed. Otherwise, whatever the containers or parts are going to deploy into the particular slave machine, it is not going to connect to the services. Then further, you don't require to do any separate configuration on the new node. You don't require to do any separate. Automatically, your daemons will be taken care. That's what one of the advantages of the daemon sets. If your node is added or removed from the cluster, daemon set automatically adds or there is the pod. What is the pod here? Your pod can be a DNS pod, or it can be a proxy pod, or it can be a wavescope pod, whatever it may be. Right? These are all the pods, right? These are all the pods, all are running here. So now these pods addition and deletion can be taken care by your daemons. That is one of the advantages of the daemon set. Right. So now it's not going to have any replicas, the daemon sets. Right, so this is one of the advantages. Now the third one is the stateful set. Right, so now here Kubernetes resource used to manage the stateful application usually contains are stateless. Right, the containers are not going to maintain the state, but yes, you can maintain the state in the Kubernetes with the help of stateful sets. Separate concept here. Right, so now here what this guy will do, this stateful is also controller to unlike the deployments, means it does not create any replica set, rather itself create a pod with unique naming convention. Right. So now here you are not going to have any replicas like 3 replicas, 5 replicas, 10 replicas. It is not going to have something like that. This stateful set. So this stateful set will be having the pods, but each pod will be having their own naming convention. Like usually, if you guys observe, every pod name we are going to give some common name, like app name, app nginx container, so that this service object is going to map this Nginx container parts to the endpoints are connected to the service object with the help of port DNS. That's what we have covered. But in the stateful set, we are not going to have the same label name for each and every pod. It is going to have the unique name, right? Because it is like a separate server. The server itself is having their own state, not like the stateful sets, stateless sets, right? So now here, this stateful set will be having their own name. If you create any stateful set name, then what the stateful set will be created, like how it will be created, like it is going to have the service name, the stateful set name, then followed by the index number, like 0, 1, 2, 3. Like suppose I am trying to create the member DB stateful set. So now the member DB, I want to have the 3 copies, not like only one. So now, but it should be their own stateful set. Like I don't want like the volumes mounting something like that. So there, what it's going to do is member DB0, member DB1, member DB2, like that is going to create. Right. So every replica is nothing but their own 0, 1, 2. Stateful will have their own state because it is going to have their own volumes. Earlier, we are going to use a common hard disk space, a common volume that will be connected by every pod, multiple pods. Now here it is not something like that. It's going to have their own volumes, like a separate virtual machine. Simply a separate virtual machine. Right. So every replica of a stateful set will have own state, and each of the pod will be creating own persistent volume plane. No common volume for the pods. Each pod will be having their own volume. So volume claim. So stateful set with the 3 replicas will create the 3 pods, and each having their own volumes. Means total 3 volumes you are going to see as an example. Okay. So right. So now here that is what the stateful set. Stateful set. If you want to create the stateful set, this is the example, guys. So here the kind type will be, we are going to make a stateful set. So then it is going to have their own storage space, 50 whatever it may be. Then the storage class name we are going to mention, like as I told you, different plugins are available like EBS, EPF, EFS, Azure Files, Azure Blob, something like that. So now this is the storage class we are going to mention, and say the rest of the things are same, right? The volume mount, which one you want to mount it, and this is the climbing. Things will be same, but here you are going to see kind will be stateful set. Right. So now here the stateful set is nothing but the stateful sets are nothing but the parts are going to create, and the parts will be having their own unique names, and each part will be having their own persistent volumes. So not like the stateless. This is the state, right? So now here each part will be like 0, 1, 2, 3 is going to create, and every part will be having their own volume. So now the deletion will be how the deletion will be happen in an order, right? So now here if I want to delete the stateful set, if I want to create the stateful set, then the order will be something like that, right? So here I want to have 3 stateful set containers. So now here what this guy will do, this is members -0, this is members -1, and this is members. This is like how it is going to create. So now here first it will start from the 0, your cluster, right? Once this is created, it is up and running, then it is going to create the 1. Until unless it's not going to take any action on the other copies. But in our stateless, it is not like that. It is going to create the 5, 10, whatever replicas you are going to is going to launch immediately. But here in the stateful set, it will be taken care of the creation of first one. First one is completely created and launched, then it will be taken care of the second one. Then it will going to taken care of the third one. If I want to delete it, then it will start deleting from the third one. Once the third one is completely deleted, then it will go to the second one. Once the second one is completely deleted, then it will go to the first one, like that. Like that, the flow is going to maintain the initial creations or deletions in the stateful set. Right, guys? So now here, these are the daemon sets, stateful sets, and the deployments. So this is one of the intro question for us actually. So then, taints and tolerance. Taints and tolerance are nothing but we are going to give some names, some label names to the slaves, to the nodes in the cluster. So here, if I take this is the cluster, if I take this is in a cluster, master, slave, then here I am going to provide some taint names like a labels. So now here the taint names we are going to attach or we are going to label to the nodes. Then whatever the containers we are going to launch inside the slaves, those will be having the tolerances. Those will be having the tolerances. We are going to mention the tolerance. Now here this tolerance has to match the taint name. Then these parts creation will be taken care. If the tolerance are not matching with the taint names, then the actions is not going to be taken care. Right. So now here proper resource consumption. Right. So you can have the taints and tolerance, nothing but you can give the taint names to the node servers on the cluster. Then what are the containers, nothing but the parts, what are the parts you are going to create. Now the parts will be sending the tolerances. So now the tolerances are matched with the taint name, then the actions are going to take care. Otherwise, no action will be performed. Now the action can be a creation or deletion, anything the action can be on the pod level. But the taints and tolerance has to be matched. Right. So now here like a better resource consumption, that's it. So right, so now taints and tolerance in the Kubernets, dedicated nodes, node with the special hardware, right? A better consumption, resource consumption in a better way. Right. So now here working with the taints and the tolerances. So now here you can see observe here kubectl taint nodes. Right, as I said, a taint name we are going to provide on the nodes. Right. So here taint nodes. Nodes are nothing but our missions. My one of the mission called host one, host one, host two, host three. And so now host one. And so here special equal to true, no schedule. I have given the taint name as a no schedule special equal to true. Then what will do? Node host one is tainted. Right. What is the taint here I have given? No schedule. Special equal to true and no schedule. This is the taint name for the host one. Right. So now here the taint has in the format. What is the format here? The taint key equal to taint value, taint effect. Taint key equal to taint value, taint effect. This is the format actually for every taint on the node level. Right. So now here this is what the format which we are going to provide. So now here this is the effect. So now here there are different effects are there. Schedule, no schedule, prefer no schedule, like that. The effects apart from the no schedule, you can have other schedule like no execute, like that. Just go through it, guys. You will understand. So now here once the taint is created, then you are going to see somewhere the column as a taint on the node. Right. So now here once the taint is created, right, then tolerances. Right, as I said, whatever the parts you are going to create inside the cluster, now the parts will be sent as a will be attached with the tolerances. Now these tolerances are going to match with the taints. Right. So now here this is a part. Suppose now in the part we are going to add a section called tolerances. Tolerations. Sorry. Right. So now in the tolerations, what is the key? Key is a special. Right. So here see here. What is the key here? Key is a special. What is the format? Key, value, effect. Key is special here. So now in the part, we are going to mention in the part section, in the tolerations, my key is special. Now there are different operators are going to support, like equal to, not equal to, something like that. So now the now the key special equal to true value, effect, no schedule, right? These are the two from the our taints. Right. So now here what I'm trying to tell my part is, if my key equal to special, right, my special is having a value of true and a value when the effect of no schedule equal to means matching, right? Yes, matching. So if it is matching, then don't take any action. Right, so now here the part toleration, the key is special and the value is true and the effect is no schedule. Right. So now here what the effect? Don't schedule it. Don't take any action. Right. This is what here. So which exactly matches the taint we applied earlier, right? Therefore, the pod can be scheduled on the host one. However, this does not mean that pod will be scheduled once the exact node because it's a node selector. That node selector is a different story. I will tell you later. Right. So no schedule, don't schedule it. Right. So now likewise you can have the operator called exist, special. Like these are the different criteria in the operator. Now earlier we have seen the equal to. Now here you can see you can check like exist. It is exist or not. No schedule is there or not. Effect. Yes, it is also matching. It is there. Right. So likewise we can have the schedule not schedule. So here see here schedule and not schedule. Let's see tolerances key GPU key other. GPU equal to no schedule schedule. GPU key is others, not others equal to true, no schedule, not schedule. So let's see here. Okay. So different set criteria. Like likewise, you can have multiple taints and multiple tolerances. Means for same host, you can add multiple taints. One is the no schedule, one is the no execute, one is the no schedule, and the key is value one, value one, value two, like that. Means you can add number of taints on the same host. Then also you can pass number of tolerances also, tolerant one and the tolerant two, like that. Right. So now here, these are nothing but the effective resource consumption with the help of taints and tolerances. Right. So now here, if you understand, if you are trying to observe the difference between our Docker swarm and the cluster, right? So in the Docker swarm, I have the master, I have the worker nodes. In our Kubernetes, we have the master, we have the slave. But the difference here is on the Docker swarm, the master is also taking the load. But on the Kubernetes, this master is not taking the load. He is not going to have any kind of pods. Pods means application side, like the end user, like you and me, whatever the pods we are going to create, those are not going to deploying on the master. Right. So now here, but in the Docker swarm, the master, even there is a master, is taking the load. Right? Why this master is not taking the load? Because the taints and tolerance. This is the section. This is the section which is not allowing to us to deploy the pods into the master. Right. Now you understood, right? So now here means if I remove the taints and tolerance, you can launch or you can deploy the pods into the master. Yes, you can launch. If you allow the tolerance or you can change the tolerance so that you can deploy the pods in the master also. Now here we have mentioned by default on the cluster side, the taint and tolerance are set up something like that. Don't deploy any pods on the master. Default behavior. You can update it or you can remove it so that you can deploy the pods in the master. This is also a question, guys. Right. So now let's see. Right. So here kubectl get nodes. Let me go to the master. I have total 4 nodes are there. Let me go to master kubectl describe node. Now here you can see these are the complete details of about my master node. Then here you can see somewhere the taint section. Taint, no schedule. So now the taint is added on the master, right? Don't schedule anything. So that is the reason. Yeah, this is the like it is in the master, like key value and effect format. Key value and effect format. Like on the master, no schedule. Default. The taint is added something like that. So that is the reason no parts are going to deploy in the master. Now if you updated it or removed it, so you can deploy the parts in the master. That is what the taints and tolerance guys. So then RBAC. RBAC is one of the feature in the Kubernetes, like you can restrict the users to connect or to access the cluster. Right. So only the admin should have the what is called uh, uh, complete access. Only admin should have the complete access on the cluster so that they can perform anything. but the developers or the other folks should not have the complete access. If they want to fetch the information, they can fetch it, but they cannot do any kind of modifications, or they cannot do any kind of creations or deletions. Right? Only the admin should have the complete access. Right? So how we are going to restrict them in the Kubernetes? So that's what the RBAC here. So now here on the Kubernetes side, if you want to restrict the people to perform the operations, then you can set up the RBACs, right? So like here, how the RBAC is going to set up. So now the RBACs can be set up on the user and the service. Right? You can have the users, or on the service level also you can set up the RBAC. So now for the users, you are going to create the roles, and the roles are going to bind it. Role bind. Now on the service level also you can create. Now we are going to create the cluster role, and the cluster role are going to bind it. This is what the process. Right? You can have the users, you can have the services to restrict the access. Right? On the user level you can restrict, on the service level you can restrict. If you want to create, if you want to restrict on the user level, you have to have the user. Then for the users, you are going to create the roles, and the roles are going to bind it so that you can restrict. On the service levels you want to do, and the service are going to create, and the service are going to cluster roles are going to create, and the cluster roles are going to bind with the service. Two more. So now here, right? So here by default, the Kubernetes is not going to support give any kind of user creation stuff. It's not like that. So now here, what you are going to do? We are going to have, we are going to create a PEM file, nothing but a dot key file for a user. So with the help of a tool called OpenSSL. This is a utility in the Linux. With the help of OpenSSL, you can going to create a private key PEM file for a user. Then with this PEM file, you are going to create a a CSR, certificate storage repository. Then finally, we are going to create the certificate, nothing but the .crt. So now here, this PEM and this certificate, this CSR is not going to utilize. This is the intermediate process to create the certificate. So once you got the certificate, then this key and the certificate are going to utilize. Key and certificate are going to utilize to grant the access to the user. Right. So now here, this is the user creation step. So now here, with these are the with the help of the keys, you are going to make the user not like way create a user, something like that. So now here, once the user is created, then you are going to create a role. So now this role is nothing but the authorization. Right. So now here, nothing but the access level. So now here, what kind of access you want to provide? Right. Only retrieve access, or you want to give the write access also, like pod retrieval access. I want to give only pod retrieval access. That's what the role I am going to create. Access level on the objects, the cluster. So now this role is going to bind to the user. That's it. This is what the process actually. Right. So now here, this is we are going to create a private key and the certificate for user. Then the role will be created. Then in the role will binding to the particular user. Right. So then the same thing. This is on the user level, and this is on the service level. Same thing here. So for that here, if I go to cd.cube, if you guys remember or not, there is a cube directory we are going to create, and inside the cube we are going to have the config file. Correct? The config file is nothing but the authentication to the cluster. If you want to connect to the cluster, this config file you are going to copy and paste it to the users directory called .cube. Now this root want to connect to my cluster. Then what I did, inside for the root I have created a directory called .cube. Inside the cube we have placed the config file. Yes, you can observe this in our installation steps also. Just I'm going to show you. This is a step. Make directory home, user home directory dot cube. We are going to create, and we are going to copy the admin configuration file, Kubernetes admin file into the as a config file of the cube directory of the particular user, right? So this is what that is, right? Cube inside the cube, I have the config file. So now this config file is nothing but your cluster authentication, your cluster connectivity file, communication details. So now you can see here that the version API version is the thing, then clusters, right? This is my cluster certificate, and this is my cluster IP and the port number, the connectivity, and this is the cluster name called Kubernetes. Right. So now there is a context. Context are nothing but the user who is right now who connected to the cluster. Right. So now here namespace user is as of now nothing. Here Braille Kona is the context we have created. This context is currently connected. See here current context. Sorry, not the Braille Kona. So here the current context is the Kubernetes admin. Kubernetes admin is connected. Just now admin means you can perform any operations. You can create, you can delete, you can modify because it's an admin. Right. So now here on the cluster, we have the context as nothing but who is connected to the cluster. Right. So now this is the default context and this is the current context, nothing but on the Kubernetes cluster. This is the Kubernetes name on the cluster. This is the namespace, right? Which namespace you are referring here? Braille Corner namespace. Under the Braille Corner namespace, this is the user called admin. And the name is, the user admin name is, this is the one, and it's connected to the current context. So now here, this is user level. This is the cluster level certificate, and this is the user level certificate. And so here, if you guys observe here, this is the what? The certificate. And so now here, this user level certificate, nothing but who is the day? This is nothing but the user called Kubernetes admin. Right. So now this admin certificate is provided here. User, then this is the client. This is the cluster, and this is the client, nothing but the user admin. Right. So this certificate is going to connect certificate and the key. Right. You can see here certificate and the key. Nothing but here key and the certificate. Right. We are going to create this key and certificate in the OpenSSL. Right. So this cluster is required key and certificate for the user. Right. So that's what here. Key, certificate, and the key. Both here it is passed here. Now these will be authenticated with this cluster, then the communication will be established so that this user can perform. Who is the user here? Kubernetes admin can perform the operations. Right. Right. This is the config file. Now here, if you want to create the users, if you want to give the access on the user means this config file is going to modify. It's going to modify means it's going to update with the users information. Tomorrow I'm going to create Shankar. Day after tomorrow I'm going to create Chris. Those guys will be added in the config file. And the context for the user Shankar and Chris, I'm going to provide the context. Then finally, the current context means who is connected right now. Right. So now here on their local machines, right? So the Shankar is working on this laptop, right? On this machine. Now he is going to have their own current context, like the Chris, like the Rajesh, like the Teja, like that. Right. So, right. So here for that, as I said, you need to create the user and you need to create the role and you need to create the role binding. This is the cluster role. This is the service level. Cluster role means service level. This is right role binding. Suppose if you guys observe here, right in the process, users, roles binding. So if I go to the role binding here, the role binding name is read parts. Right. So now here, see here user. Right. So now here, this binding is going to do for the user roles binding. Right. What is the role binding here? The role means the access level. The access level. Right. So here, this role binding nothing but reading the parts, nothing but for the user called Jane. One second, guys. Right. So now here, this is the Jane and the role reference, right? So which role you are going to bind it for the user? I want to bind the role called pod reader. So means one role has to be created. Now this role will be having the access level of what kind of access you want to provide to the people. Right. So now this is the pod reader is the role, and this role, this pod is going to bind with the help of role binding to the user called Jane. Right. Let's go down so that you can see. So that you can see somewhere the role section also. Role binding example role. Right. So now here the second part role. So now here the role is nothing but the access level. Let's say here I'm going to create a role here and the some name, like what is the role name here, and this is the rules, nothing but the access level. Right. Now here you can see API groups, right? So how we are going to know the API groups? Right, simple with the help kubectl. Right, you can see here API versions, API resources, other commands. And here let me show you kubectl API resources. Right, these are the things. See, API groups. So for the API resource, this is the API group. Right, for this API service, this is the, right, you can see the groups here. Sir. Right, so now here on the groups, you are going to take the API groups, then you are going to provide the access on the group level. So now here you can see pods and the nodes. These are the group names, metrics.kx or something like that. Right. So now here API groups as of now space means I'm not giving any specific API group. Then here in the API group the resources, like these are the resources, these are the API groups, right? So this API groups can be anything, but these resources I want to take the resource here, the parts and the parts log also, right? And the part log also, just I want to give that. Here the verbs are nothing but the actions, what kind of access level you want to provide. Just I want to give the get access and the list access, no creation, no deletion, like that. So like that, those roles are going to create, and these roles are going to attach to the users with the help of the role binding, right? So that's what here. So likewise, these roles and roles bindings are going to create, and these are all the same examples. Like you can see, you can go to this documentation. You can see here. Go discovers. So this is what OpenSSL. That OpenSSL, we are going to create the certificates with the help of OpenSSL. So you can see authentication strategies. Let's see here you can see I am going to request for a new key PEM file, right? The key file, some name and the PEM file. And this is the CSR, certificate storage repository. And this is the subject, nothing but here who is the guy for whom you want to request for the key, and iPhone or nothing but here this is the group information, like app1, app2, some group information here. So here two groups are created, app1 and the app2. So now this would request a CSR for the username, this way. And so now then here once that is created, and then you can have the, this is what you can set up the configuration of the credentials, like the username, and here we are going to provide the secret, client secret key and client authorization token. So this is some detail. Getting a bearer token, bootstrap token. So it's like don't require that much. So this is OpenSSL, create a user account. So create record. One second, please. So here we are going to create the same story here, the creating a new request. So for this is the group Bob and DevOps. And then once the CSR, then CSR, then it should be create the certificate is required actually. So here they have created this access certificate. This is a certificate. Yes, CSR. To view. This is how we are going to set up the user actually. So set up, in between the certificate creation is missing. That's what I mean. Okay, fine. So I will check it. I will give you the link. So to create the certificate step is not showing here. So that's what I'm looking for actually. With the key, we are going to create the certificate. Then the certificate we are going to use in the config file to connect to the user. That's what actually. Role open stack. Okay. Anyway, I will find out that link and I will share you the link. Guys, just go through it. It's not mandatory again. So, but for the information sake, just for understanding, this is the RBAC setup. Then the final one is the health probes. The health probes are nothing but right. So when I'm going to create the pod, right? So if the pod is properly configured with the prerequisites, everything is set up properly, then finally the container, the pod is going to up. So now here we are going to place the health probes are nothing but if the pod is up and running or not. Suppose here the thing is, if you guys remember, we have the deployment strategy called recreate. Right. So what the recreate will do? So now here this is the version 1 is running, and this is version 2. I want to launch. So in the recreate, what will happen when I'm going to deploy the version 2? So first it is going to terminate the version 1 first. Then we're going to launch the version 2. So now when it's going to launch the version 2, there is some problem happened. Due to the problem, the container is not up. There might be n number of reasons. Right? So with one of the reasons, the container is not up and running. Then what will happen in your application? Your application will be done because it is the previous version also. Right? That should not be the case. Right? It should not be like that. That means if you are using the Kubernetes, you are going to use the Microsoft means your services should be up and running always. There should not be any downtime. If you are seeing the downtime of the application means the tool you are not utilizing the tool effectively. That's it. That is not the problem with the tool. You are not using the tool effectively. Right. So now here the thing is right. If you want to handle the situation there, that you can validate. You can check the health probes. My health probe is now what I'm going to do. I am going to validate whether this container is up and running or not. Right. If the content is up, and then I'm going to validate the application is up and running or not. Right. So now he usually, if you guys remember our Tomcat, will be running in the right. The application will be deployed in the Tomcat where in the deploy inside the deploy folder, right? So there. So now I'm going to tell my health probes are nothing but let's first check the container is up and running or not. If the container is up and running or not, then go and check in the deployment location where the application is accessible or not. Right. So two health probes I am going to check. Right. So now here how we are going to check. So here you are going to see readiness and liveness. Readiness and liveness are nothing but the health probes of our pods. We are going to call it the readiness and liveness probes. Right. So now here I am going to check the liveness, nothing but my pod is up and running. Okay. So now here the like how frequently you want to monitor it. How frequently you want to monitor it. Let's initially delay of 15 seconds and create the frequency. So now here if the timeout seconds, right? How like I have sent a request, how long I want to wait for. It's like 1 second or 2 seconds because you have to respond immediately. Otherwise, now if the application response taking 10 seconds means your application is not properly developed, not properly responding, your infrastructure is not good. So that is not responded. There are a number of reasons again. Right? So now here this is what the threshold values to validate your application. So now here in the readiness, I am going to check my application accessible path, like the deployment location of the Tomcat. Right. So here, one of the containers up and running, then I'm going to check the application is usable or not. Usually, your application will be somewhere it's going to deploy. If it's Apache where HTML is the location. If it's a Tomcat deploy is the location. Right. So those are the deployment locations. So now we are going to reach that. You are going to hit that location so that if you get the response means application is reachable. If you are not going to get the response means your application is not reachable. Right. That's what in the both case either any case or both the case are failed, then you don't take any actions. Right. If both the cases are satisfied, then only take the action. Right. So better utilization of the resources. Right. So now here that's what we are going to call as a readiness and liveness probes, health probes. Right. So we are going to check the content up and running with the port 80, and here we are going to check whether my application is reachable or not. This is my application location for me. For you, something will be there, the deployment location, and this is what our again threshold values. Like so, this liveness and readiness probes we are going to place where in the deployment object. In the deployment object, that's it. So under the spec, nothing but your container creation. Right. So this is what. Right. So likewise, you are going to have different sections. Still more are there, but these are somewhat useful sections. The objects in the Kubernets. Right. So just try to explore these things, guys. These things at least. Just have at least have a theoretical knowledge. You don't require the practical knowledge. At least have a theoretical knowledge. Right. So now we are going to take a break for here 15 minutes, then we'll come back and we'll try to set up the project. Right. So now here how the CACD is going to happen with our Kubernetes, right? Now our microservice CACD process. Okay. So we'll try to set up from the scratch. Maybe today we are not going to set up. We'll try to set up the infrastructure. Then tomorrow we'll continue the CACD process if the time is not sufficient. Okay, right, guys. So let's take a break and we'll come back. Then we'll try to set up the CACD project. Right.
Okay.
This conference will now be recorded.
It's taking some time to load. So, okay, so I am going to go to the service of AWS is EC2. So from that, I am going to create a Jenkins server. Right, we require Jenkins server to deploy our jobs and nothing but the CI/CD jobs. So let me go to the running instances, launch instance, and select even launch. Right, so from here, I will take the Jenkins installation steps. Now this is my Jenkins. Connect, copy, dash. Java installation. Development kit, then environment variables, right? Java home and scenario home and source etc profile. Right, then Jenkins. Right, so the main term I will open the ports. Say, right, so now service Jenkins start. That's it. Now Jenkins is ready. Right, we require the key, right? So the key you can get it from cd cat where live Jenkins secrets initial admin password. This is the key, right? So this key you can take it from here and unlock it. Right. So now here install the plugins. Now here to set up this one, I require the Jenkins. I have installed and I have configured it. Then I require the Sonar cube, right? So for the code quality. And on the Jenkins, we require Docker. We require Git. We require Sonar scanner, right? These are the tools are required. And for the Java, Maven tools. Tools which are required on the Jenkins, these guys. Docker, Git, Sonar scanner, Maven, right? So now here a separate service requires SonarQube to publish the code quality, right? So to publish the code quality, and Docker Hub is for to store the images, correct? Nothing but your images repository. Then you require the Kubernetes cluster. Deploy the application. Right. So these are the tools are required for us right now. Right. So Nexus is not required. Instead of Nexus, Docker Hub came into picture. Right. So now we have done with the Jenkins. Now go to country Jenkins. Retry. Fine. So now here in the meantime again go to the launch and select, and here right we require T2 media. Right. So our cube is not going to run on the T2 macro, so I'm going to take the T2 media. Launch on this is I'm going to give it the name Sonar. Connect to the Sonar. Same step, same reputations. Right. Then So I'm going to copy into embed repository. So let me set the file name. Sonar repo into embed repository, then install sonar. Service sonar start. Perfect. Now let's refresh it. Security groups are not open. That is the reason we are not able to access it. Sorry. So I'm taking the Jenkins server. That is the reason it is not able to reachable. So I have to take the SonarQube server. Right. So this is the one. Sonar also ready. So now here we have the Sonar, we have the Jenkins, and we have the cluster. I'm not started it. Will once the setup is done, and then I will start it. So right. So now all the setup is done in from the infrastructure side. All the servers are ready. So then what else I require? I require these tools, and I require the Docker Hub. Right. So let's go to the Jenkins and set up these tools first. So I will go to the Jenkins and start installing of the required, required tools. Manage Jenkins, correct? Manage plugins. Available. So here I'm looking for Sonar. Then Git, Docker, Maven. Git, Docker I'm going to install on the server, and Maven I'm going to install from the global tool. So as can be sufficient. So download, install, download now, and install after restart. In the meantime, go to the Jenkins, yum install git -y. Git version yum install docker -y. Yum install docker -y. Install spelling is wrong. service Docker start. Service Docker start. Service Docker status. Running. Right. So now here Docker run hello world. Just for confirmation, Docker working or not. Yes, it's working fine. Absolutely. Right. Good. So now here restart is required. Let's restart the Jenkins. So now here from the tools, I have installed the Docker, I have installed the Git on the server and the source came from the plugin and the Maven I'm going to install from the global tool configuration. Let me go to manage Jenkins. And global tool configuration. So here I'm going to take the Sonar scanner and install automatically. Name Sonar Q. This is one thing. And the next one is Maven. Maven install automatically. Apply save. Then configure system. Here go to the Sonar Q server. Here Sonar Q. Then Sonar Q and the server URL is 9000. Right? For the Sonar we don't have any password. So application between the Jenkins and Sonar Q. Done. These are done. This is anyway I have the login. I have a Docker, I have Kubernetes is ready. Right. So let's see the process now. Right. So now in the process, what the process will happen whenever the developers are ready with the code means their future the sprint branches. Then what they will do, they will raise the PR pull request for what? For the future branch or the sprint branch to the develop branch. Correct? Then you review the PR and merge it if everything goes fine. Merge it to where? Into the develop. Then in the Jenkins, the dev job is going to trigger for how? With the help of webhooks. Right? We know very well the setup. Now here in the job, usually the common steps, unit test case, validation, then code quality check, then Docker image build, then tag the Docker image, Then push the Docker image into the repo. What is the repo? Docker Hub repositories. By push the Docker image to the repository, tag the image, Docker image with the version and push the Docker image to the repository. Then finally deploy the latest image from the repository to Kubernetes cluster. This is the flow which we need to build, which we need to set up. This is the flow in the Jenkins side, right? So now here we know until this part. This is the common steps for your monolithic or the microservice, and this is the new step which we are going to see now. These are the new steps. Right. So now the thing is right. So how we are going to set up with the help of Jenkins files or our pipelines. Right, in the pipeline we are going to set up. So now here I will go to GitHub. And I will go to this repository and I'm going to set up this one. So I will go to Jenkins, create a job, and here game of life micro deployment, some name, pipeline. You can OK. And here pipeline from SEM. And here I'm going to choose the Git. And here my repository is this one. Since it's a public, permissions are not required. And I'm pointing to the master branch and my file is Jenkins file. Let me see my Jenkins file is the same or not. Here Jenkins file docker deploy I have, Jenkins file I have. Let me see what is this file. Correct. So this is the one which I'm looking for. So I will take this Jenkins file docker deploy. Apply and save. Now what are the steps are there? Let's see. Picking the repository, GWL repo, and see, these are all the command lines. All the command lines. Only this is the one. Then build, right? Maven installation. Right? So installation means Maven is going to take care of the unit test case validation also, right? So the first will be the validation, then test, then package, and deploy, right? So the unit test case will be validated here. Then publishing the results with the help of JUnit. Then this is the step of our SonarQube. SonarQube and the Sonar scanner will be run against on the code, and this is the quality gate. We know we have seen this one also. So then artifact upload I have committed because now these are the we are not going to push the war files or jar files. Simply I'm going to manage the Docker images. Right. So now here you can see build and push the Docker image step. I have placed it. So nothing but I am going to run the script of Docker build -t and my image I'm going to create with the name game of life image. Right, we know to create image Docker build -t is the command. Straight away I'm running that. Sorry. So then I am going to tag the image with the build number, right? Versioning. So now once the image is built, tag it, right? We know why the tag is required, right? If you are trying to push the image into your repository, your Docker has to know which repository has to be connected, which account has to be connected, another which repository, and where the image has to be stored. That is the reason we are tagging our image, whatever we have built with the previous step, to the Docker IO into my account, into that account with this naming convention. Then finally, I am going to push the image. Right? So image is ready and image is going to store into my repository, Docker Hub. Right. So now this is the some other step, nothing but our image updations and deploying into the cluster. Right. So now here my application is the game of life application which I want to deploy into the cluster. Right. So for that, what I did. So what I did here, if you guys observe, you can see here I'm trying to deploy a file called deploy-cube.yaml file. So let me go to the deploy-cube.yaml file. What is there? It is a simple deployment manifest file. It is going to create the 2 copies, and the app name is a sample container. And here you can see the pod name, sample pod, and you can observe here this is my path. Which path? My Docker Hub repository path. Wherever my service I am pushing into the Docker Hub, the service path is something like this. From that, I am asking to pick the latest. Right. So now here, if you guys observe in the previous Jenkins file, the latest image always will be so the latest image will be always pointed or tagged, right, with the build number. Suppose if I'm building one, means one is going to tag it, but in the deployment file I have mentioned like take the latest. So now here that is the mismatch, correct? Because your changes will be pushed with the build number, but you're asking for the to put the latest. That is the reason. Before deploying this file into the cluster, we are trying to update the file. Which file? This file. For what? To update from the latest to build number. This is the step. Right. So now here in the deployment cube app file, what I'm saying here is wherever you find the latest, if you guys remember or not, the set command in the Linux, find and replace. Right. What I'm telling here, if you find anything with the word latest, change with the build number. Right. So now what will happen? The image path latest will be replaced with the build number. So now it is going to match. So the match means in the GitHub repository, I have the same image with the version. It is going to match. Then I am going to deploy it. Right. So now here your Kubernetes, you are going to deploy into where? Into the cluster. Into the cluster. Right. So now from where? From the Jenkins. So now this guy has to connect with the cluster. Then only can perform the operations. So for that, what I did here is I am trying to copy my YAML files. My YAML files from where? From the Jenkins to where? Into the Jenkins of the target. Right. So now first what I'm trying to do here is I am trying to connect from my Jenkins to the master. To the master of the Kubernetes. Then my whatever the YAML files are there in my Jenkins, I am asking to copy into the this so and so location of the Kubernetes. Right. So then once the files are copied means the YAML files are nothing but the deploy.cube YAML file and the service.yaml file. Right. So now here the deployment file just now has seen nothing but it is going to pick the image from my GitHub repository and it will going to apply on the cluster. Yeah. So then I want to access the application. To access the application, which what is required? We require the service file. So if I go to the service file, we are going to see the same sample container, the app, and here the service name, and here you can see the application is exposing with the type node port, and I have given the port 300 for some port number. Right, with this port number, I can access the application. That's it. Right. So now this is the deployment file and this is the service file, or you can put both together in a single file, however you want to maintain it. Then this is my Jenkins file. So now here, if I want to run this job, before what I need to do, I need to establish the communication between the Jenkins and my what is called my Kubernetes cluster. Right. So now here, let me connect to the cluster. Connect, copy, kubectl get nodes, kubectl get nodes. Right, perfectly working. So now here, what is required here? I required the Jenkins has to connect to the Kubernetes. So now here, this is the Jenkins, su Jenkins. Alright, so here by default, cat etc pssw. Default Jenkins will be in the false. Alright, so here Jenkins has to be updated. You can run the command directly. Let's see. Okay, fine. Okay, fine. Let's update it. Chmod hyphen yes bin bash for the Jenkins user. No such file for the user mod, I think. Not the face mod. Bin bash Jenkins. Alright, so now cat etc pssw. I can now su Jenkins. Right? I can log into Jenkins. Fine. So now here I have the user ready on my Jenkins server. Now I want to connect to the master. So what I will do, user add Jenkins. Right? So cat etc pssw. Jenkins you can see here. So now here let's switch to the Jenkins. Right? So here I can see Jenkins to my pwd. It's not there. Cannot see it from the Jenkins. Okay. So here let me change bin sh to bin bash. User mod hyphen yes means shell, right? Bin bash to Jenkins. Now su Jenkins cd pwd. Home Jenkins no such file directly. Cat etc pssw. It is changed, but it is not showing me. My phone directory. Exit. Yes, and W Jenkins. 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 User Dell iPhone R. Jenkins. Sorry. Exit. User Dell iPhone R. Jenkins. I'm going to create the Jenkins. Cat etc pss etc pss wd. Now the Jenkins one. Add user Jenkins. 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 Jenkins something. Yes. SU Jenkins. Hmm. So here in the Ubuntu, this is Ubuntu version. So that is the reason user ID is not properly working. Use add user instead of user ID, add user. So now you want to ask the password and give some password. You can leave the blanks as it is. We don't require to give the information. Then you can see from Jenkins. Right. So now here I have the what is called Jenkins user ID. So SU Jenkins and what I'm going to do cd sorry mkdir dot ssh. I have created a dot ssh. Then inside that ssh we authorized underscore keys is the file I'm going to create inside the dot ssh. It is an empty file. Now let me go to the Jenkins server. Su Jenkins cd pwd. I'm in the Jenkins cd dot ssh. Nothing is there means I don't have any private key and public key. SSH hyphen keys and I'm going to create a public key and private key for the user called Jenkins on my Jenkins server. Leave it as it is. Then it's going to create a .sh folder. Inside that we are going to find the keys, open the public key and copy the public key from here to here. Then go to our cluster, paste it and save the file. Right. So now here let's go to let's take the private IP or the public IP, anything is fine. And I will go to my Jenkins from here, SSH Jenkins at the rate server. Yes, done. I have connected to my cluster 130, right? So SSH communication is happening, and thus the next, right? So here, then let's trigger the job and see, right? So click on build now. It should fail somewhere. Let's fail it and see the issues. Fail Maven. So here the tool type Maven does not have an installation called Maven configuration, right? So here the thing is, in my Jenkins file, the tool name I have given as Maven, capital Maven. So that is the reason it is failing. So what I will do, Jenkins, manage Jenkins, global tool configuration. Right, tools installation is the part of global tool. Right, so go to the global tool and go to the Maven installation. Here, change it as capital Maven. That's it. Apply, save. Now go to the job again, Jenkins, go to deployment, click on build now. So some steps are passed, I think. Checking out done, and here Maven is going to execute. In the meantime, let me connect it to hub.data.com. Already I connected. Right? This is my repository. This is already connected. Let's see. Build success. Sonar cube step is executing. Failed. Now here the reason could be here a sonar. Right? So game of life 4 is not exist. Fine, right? Now we can understand what kind of error these are, right? We can able to resolve it. We should able to resolve it. Right, so here it is trying to look for the game of life 4. It is looking for the game of life 4. So here let me go to my repository, and here wherever the application, right? This is the code. Now you can find a file called properties. Right, so here my job name is GOL micro deployment, not the game of life core. So let me go to here in the properties file. You are going to see it is looking for game of life core. Change it with your job name. Save it. Now the song clip again started. Let's see. Again, it's got failed. GOL master. Right? So the folder where live works well game of life GOL deployment does not exist for the GOL master based directory. Space game of life. So here the simple solution is cd where live Jenkins cd workspace. Right? What is the job here? GOL micro deployment. Where I'm saying like one more thing I have mentioned. Right. So this is the path actually, my sources. So I'm click started again. Let's see. taking some time because of the code is a huge code. Let me change this one. Instead of scanning the entire project, I'm going to tell go to this particular directory, game of life 4. I'm going to tell scan only the game of life core only, not the entire project. This is the one. That's what I will do. It's become slow. I'm going to load up. I'm going to reboot it since it's taking much time. reboot also not working. Maybe the low configuration is not able to pick the resources and is not able to do it fastly. Something went wrong with the Android actor system. Is there something? Now restart it. Trying to execute it. Stop this one. And let me build it again. Fine. So now it will take only the part of the code, or the code quality should not take the entire code. That's what my intention is. Because I have given as take only this particular directory code. This is the one. Right, so here you can see analysis success. Analysis success. Right, so here the status on a student server is failed. So the reason could be our Jenkins is not configured in the software. Admin, admin, skip this tutorial, administration, configuration, webhooks, correct? Create, Jenkins, Control C, Control V, and here I'm taking a Jenkins server IP and SonarQube webhook. Control C, Control V. That's it. Copy, and I will go to the SonarQube stuff, remove it, and add it. Create. Right. So now this is configured. Now let me rerun the job again. Now SonarQube step got failed because quality gate. Still it is failing. 3, 15, 41, 0, and so see here, it is new one and there it is showing the old one. The pointer got here. Invalid JSON system show. Let me put this on queue. Jenkins, Jenkins, manage Jenkins, configure system. It's fine. 119. It is looking for 119. Jenkins here. But anyway, this is not required. Let me see the error again. Agent 2331700. 31 perfect. So good. Okay, we'll do one thing. Time being, I'm going to comment this line. You'll see. Time master 1, 2, 3. this code quality gate checkup step I have disabled. Let's see what will happen. Geo master is correct only. That's it. So this is something not with the quality gate. Some of your task server where the JSON string. So the server actually. This is the quality gate EXR. So it is trying to point to something else. 315, 41. No, same only. So that is good. Same only, that is correct. Okay, guys. I think something is not matching. Something is not matching in sense. JSON string, something is broken. Okay, I will check today and I will let you know tomorrow because I have a meeting at 2:30. Right, guys. So we'll see this part tomorrow. I will show you because something is broken which I'm not able to understand right now. We'll see this post tomorrow.
Okay, thank you. Okay.
See you guys tomorrow.
Thank you. See you.
Yeah, thank you.
Thanks, bye.